Yeah. All right. So we are online on my channel. Okay. Well, so before we get started, I first want to introduce myself, the reason for taking this webinar. It's a free webinar, and I'm gonna tell you how many series of webinar this going to be, or is it a one-time webinar that I'm taking, or what is the next process, or all those things. Okay. So I want you guys to be with me throughout this webinar that I'm taking today. I will not take your much time. It will be 1 to 2 hours only. Okay. So just be with me for this particular time slot. Well, so as you all know, I thought of taking a free webinar on CCNP Enterprise, and the topic that I'm going to discuss is BGP. Okay, I could have gone with any random topic, but since this is a CCNP track, so I thought we all might be having a little bit idea on a BGP protocol, and I'm specially focusing from the interview point of view as well as from the Cisco certification point of view. Okay, so the main reason for having this webinar was you all know the situation due to COVID-19 is not really good all around the world. There are a lot of engineers losing the job. There are a lot of uh, decline in the offers. So I thought let me take one webinar where I can discuss, I can refresh the topics in the BGP syllabus. Okay, well, so that's the only motive for taking this webinar. Okay, I want you guys cooperation for this. So just be with me. It's for uh, it's a wonderful, and it will be really a good webinar. So if you guys participate with me, so the first half I will just go with brush up, and the next half of this class will be more of interaction. Might be I'll put up some question, I'll ask you guys feedback or whatever you think. It's not to test how you are good with BGP. It's just about learning by interactions. Okay, so that's the best way to learn, I guess. Okay, well, so let's proceed. Let me first introduce myself. My name is Sagar, okay, and I'm a technical trainer. I'm into the networking domain for 10 years. I've been training, I train especially on the CCNP, CCI enterprise levels. I also train on security topics like Cisco AF firewalls, FortiGate firewalls, Palo Alto firewalls. I also have a course where I teach Nexus in the data center, and also I teach network automation, which is very booming topic in right now. If you know network automation using Python, Ansible, and the Cisco DevNet, so right, so that's very hot and trending topic. The course at the moment. Apart from these courses, I also have a YouTube channel which you just uh, checked. Okay, so you guys can follow this channel. You guys can see or get free of content. Lot of content will be put up. Okay, so this is the playlist, and if you see, I have CCNP material, I have the automation material, CCNA, ASA firewall, a lot of EVNG automation, lot of stuff for free. Okay, so you guys can have lot of free content from the channel as well. Apart from that, here is my LinkedIn ID. Okay, so I always prefer revealing my training background because I don't want to keep someone in a dark and just tell that I know this or I know this. It's your work that speaks out. Okay, so this is my LinkedIn. You guys can follow up me. I keep on posting some useful content all of the time. So yesterday there was a Cisco DevNet live going on. Maybe you guys might be following that, but yeah, I keep on posting all this useful information throughout my channels. Okay, so that's somewhere we can all interact, all be in one group. Okay, and yes, regarding to my upcoming courses, so this is a paid courses which I was talking about that I train, right? So if in case in future, if ever you want to enroll somewhere, you don't have to look from scratch might be we all at a time want to enroll some to upgrade ourselves, right? And we start looking up, and then we just go into some trap and we spend a lot of our hard earned money, right? So yes, so this if you feel that I'm comfortable, I teach a proper topic, then I have multiple courses with me. Might be in future, whenever you want, you can just enroll, or maybe you can ask for only videos or only workbook. I also share a lot of free content as well as. So let's say if you see my screen, this is my website, and these are some of the courses which are going on. So I have one course. Let's say I have a course, CCNP Enterprise, which is for 100 plus hours. Okay. So if ever you get a time, go here. You can download the free topology. Okay, CCNP, CCI, Encore Lab topology. It's free to download, and all the videos, all the PDFs are all shared over here. If you see, this is the content of the class that's going on. Okay, so this is a paid version, which I'm not recommending you, because after all, this is a free webinar. Okay, I'm gonna give, or I'm gonna talk about only the free stuff. It's just upgrade that I'm just letting you know if you want to. Okay, it's up to you. Regarding the free material, you can go to this link. I'll post it across on the chat window, or might be I'll give you after the call. So here are two links. Okay, one is topology link and a free workbook. Okay, you guys can just download this is a massive lab where you can practice almost every technology from your CCNP, even the CCI. Okay, this is how it looks like. This is my GNS platform. Okay, and this is where my CCNP lab topology is. I teach almost like switching, routing, BGP, DMVPN, very advanced topic under BGP, everything on one single lab topology, which you can of course get it from here. There is a download link here. Okay, and a sample workbook. Okay, I also have a workbook with more than 100 plus labs, so you can just download it for free. Okay, fine. So that's a small intro about me and what I do, what are my website, what are my channels. So it's all up to you how you can reach out to me in your networking career. Okay, it's all up to you. Fine. So let's move on. So let's move on to the next presentation. Well, so this is a most frequently asked question which student always ask me, that in 2020, do we still need to be a CCNA certified to start or to enroll or to certify a CCNP? Okay, if you're aware of the Cisco trend, okay, so you might be knowing we were following this pattern. Okay, we all started up with routing and switching, and then a lot of us went towards CCNA security or data center. There were like 9 different tracks in CCNA, and then we were supposed to move on towards CCNP, the professional track. Okay, but now this is being taken down. CCNA routing, switching, or these tracks, they are all taken out from the syllabus, and we can directly enroll to the CCNP. Okay, CCNP Enterprise. It's called as CCNP Enterprise. So there is no requisite, there is no prerequisite of having a CCNP certification and then moving to CCNP. Nowadays, you can directly go towards the CCNP. That's why I focused on taking a webinar on CCNP, not on CCNA, because you're gonna spend a lot of money on CCNA. You are gonna spend a lot of time, which you can of course do it on the CCNP level itself, and eventually you're gonna be a professional holder. A CCNP is nothing but a professional, right? So this is something which I thought of letting you know about CCNP and why to be a CCNP holder. Okay, well, this is the present tracks. Okay, and we guys are over here. This is the CCNP core paper, and these are the CCNP concentration paper. Now there is one more interesting fact. Okay, so let's say so far till February 24, 2020, okay, we were supposed to do CCNA first, and then we were supposed to do CCNP. And CCNP used to be consist of three different paper: routing, switching, and troubleshoot. This whole concept has been removed now. Okay, so at present we can do CCNP very straightforward. There will be two papers. The first paper called as a core paper, okay, and the second one is called as a concentration paper. Now you have, let's say, 1, 2, 3, 4, 5, 6. You have 6 concentration paper, out of which you can write any one. Okay, and most of us who are from the routing switching, we go with this paper, which is a advanced routing switching. Okay, NRC, we call it as NRC, advanced routing switching. Core and NRC, two papers will make you CCNP certified. Now, the interesting fact is, let's say you don't want to write this paper, the concentration paper. Okay, let's say you have cleared your core paper, and you straight away now can jump towards your CCI lab. The reason is CCNP core is now also your CCI written. Okay, so clearing CCNP core is equivalent to clearing CCI written. That's why you see this paper is been also repeated over here. Do you see the code 30401 and code under written paper, CCI written paper, right? So you just have to prepare yourself for that 8 hours of CCI lab, and very short span of time and very less number of money, you can be a CCI certified, which everyone is dreaming about, right? We all network engineer wants to have that CCI number one or other day, right? So it's very important to know what Cisco is offering at the moment. So this is a current hierarchical order to be a CCI. Okay, don't have to be CCNA. If you write CCNP core, which is very equivalent to writing a CCI written, you're good at CCI written, and you can just directly prepare for CCI lab. Now let's say you don't want to prepare for CCI lab, you just want to grab some more technical information, you want to have little more um technical knowledge or industry knowledge, then yes, you can go with one of the concentration paper. So this is being the advanced routing switching. You are a CCNP certified, and might be after 2-3 years of a technical experience, you can then attempt CCI lab. Okay, so that's a good thing about the CCNP and CCI, how they are integrated. Now regarding the exam fees, so NCore is costing you $400, and these individual concentration papers, they are costing you 300 each. Okay, so you can write all of them, or you can write one of them. So that's up to you. It's any one. Okay, any one, and this is a mandatory paper. So two paper will make you CCNP certified. Okay, now if you see here, there is something called as specialist. Now this is newly introduced by Cisco, something called specialist. So a person is called as specialist if you have 3 CCNP papers. Okay, so let's say you have one NCore and you have 2 concentration paper, total 3. You automatically fall under the specialist bracket. So there is no separate exam for this. You just need to just clear 3 papers and you are gonna be a specialist. So there is no much information about specialist. It's an optional thing, because you can straight away go towards CCI, which is much more prestigious certification in the networking domain. Okay, and yes, I'm keeping this devnet topics all separately. Okay, uh, in short, I can tell you that devnet is a newly introduced course by Cisco. It will start with CCNA devnet associate. There is a professional and also expert level, but that's not been introduced right now. So as of now, they have a CCNP and CCNA level of devnet only. Fine. Okay, so let's move on. Yeah, this is something which I just discussed, which is a comparison of old CCNP versus the latest CCNP enterprises. Okay, previously you had three modules, you had three papers to to just uh, get passed so that you are called as CCNP, but now it's only two papers. Okay, and this is the current syllabus. So this is the mandatory paper which is called as NCore. Okay, it's this, and these are optional topic. You can take either one of them. So most of guys or most of the network engineers are going up with uh, advanced routing switching. But yes, if you're good with SD-WAN, you can go with SD-WAN. If you are good with the enterprise network, designing at enterprise network, you are good with that, you straight away go and write this. You can go with wireless topic as well, or a automation topic in the CCNP level, which is called as an auto. Okay, so this is a CCNP level devnet. Okay, so this is very brief on the CCNP structures. And yes, might be you guys have already gone through the official PDF. Okay, it's not something which we cannot find it. It's totally open for everyone. You just have to go to the Cisco official website and download the syllabus copy. Okay, so this is your encore paper, the mandatory paper, which will also take you towards the CCI. Okay, which, so it's all about the topic which I'm inviting you guys to explore instead me explaining and wasting time in this webinar. Okay, so it's all there are like 80%, or I can say 60% repetition from your older CCNP modules. Okay, at least 60%, because the additional topics in the latest CCNP enterprises are the security topics. You have a wireless topic added up now, and most importantly, the network automation. So these are some topics which are at least contributing 10% or more. That is not only there. Okay, you also have topic like SD access, SD WAN. Okay, hope I'm not having a latency problem. Let me try my ping. So am I audible? Is there voice break or something? Am I audible? Are you guys with me? All right. Okay. Okay. Yeah. Sometimes there would be some latency issues. Just let me know if there is an latency issue. So I pause and I start it. Okay. Okay. So I was talking about the syllabus copies. Security, wireless, network automation, added up topics. And also we have some theoretical topics of SD access, SD WAN, and all the additional topics like netconf, restconf. Okay. And yes, the second PDF here that I have is for NRC, the concentration paper. Okay, one among the 6 papers. And these are all advanced routing. You will have EIGRP, OSPF, BGP detailed. Okay, you have some VPN technologies which needs lab and packet flow informations. There are infrastructure services, there are security topics. So this NRC consists of four parts, or let's say four different parts, and your mandatory paper consists of six different parts, okay, or I can say six section in encore and four section in your NRC paper. So that's your total CCNP syllabus, okay. Well, where is this BGP standing now? What is the syllabus for the BGP, the topic that we have selected for this webinar, okay. So under encore you will have a basic topics for BGP. So here it goes. So which talks about configuration of eBGP, which are directly connected, best path selection algorithm, and neighbor relationship. Okay, so this is from Encore point of view. And from NRC point of view, you have troubleshooting, you have address families, you have the neighbor relationship, authentications, okay, and a lot of other things like next hop, multi hop, 4 byte AS, route refresh, uh, synchronization, path preferences, route reflector, policies. Okay, so these are the detailed topics which we have under NRC. Fine. So, well, so this is our last slide of this presentation. Okay. And we are over here. That's why I just put up this. We are over here. You are bypassing CCNA and straight away coming to CCNP, which will take you towards your dream certification, CCI. Okay. All right. So I'm closing this presentation and I'll start up with the technical topic now. So I'll just brush up. Okay, I'm not going to take a very boring session and bore you guys. I'll just take very straightforward topic. What is BGP and what we have in the BGP from the interview point of view and also from the certification point of view. Okay. Okay. BGP. So I would like to know from you guys what is the full form of BGP. Okay, I know you all are senior guys, or might be some are already CCNP certified, so you can make use of the chat window and you can let me know what is the full form of BGP, so I understand where you guys stand, and so that I explain from that point of view. Okay, just a second. Okay, so couple of answers. Border gateway protocol, fine. So which year do you think this BGP was launched? So which year do you guys think BGP was introduced? Because these are some technical question, you never know the technical trainer asking you this when you attend some interview and he asks you when was BGP launched, right? Okay, so I understand where you guys stand. Okay, so let me tell you, internet, okay, this was evolved in here 1980s, and till 1994 when the BGP was actually launched, we were making use of a protocol called EGP, which is called as exterior gateway protocol, which was acting uh, as a protocol to interconnect the routes, or to have those internet functionality. But the drawback of EGP was it was not scalable, and that's when BGP was launched, and the patent, or we call it as request for comment. Okay, it was 1654. Okay, as you all know, BGP stands for Border Gateway Protocol. Okay, it's one of the EGP, or exterior gateway protocol. Now when we talk about protocols, okay, when we especially talk about routing protocols, we divide them into two. The first one being called as static, and the second one called as dynamic. Okay, you might be knowing what is static. Static is something where we manually define. Okay, and what is this routing protocol, by the way? Okay, so for someone who doesn't know, let me tell you, we have various networking components. Okay, we have various network components like routers, switches, firewalls, load balancers, proxy, servers, what else? Storage devices, right? So these are some components that we use in the networking. Now I'm talking about routing protocol, which is a language that router is gonna understand. Okay, it's something like two native US guys, or let's say two native French speaking guys are speaking in a French language, right? So that's something we can uh, resemble to, or I can give an example of. So router is an hardware, or a hardware, okay, which has its own communication. So let's say I have two routers connected next to next with a RJ45 cable or a Ethernet cable. Okay. So how are they gonna communicate between each other? How are they gonna say hello to each other? So they need a communication protocol, right? And that's called as a routing protocol. And depending upon the usage, whether you're using inside LAN or you are using over on a WAN, okay. Now this is something which I don't want to go into, LAN and WAN, okay, local area network and wide area network. So depending upon the router placement, okay, we have different protocols. So the two variations are static and dynamic. Static is something where we manually gonna define. So let's say I have routers placed in this orientation. Okay, there are some prefixes 4.4.4 and I am over here. Let's say I want to reach 4.4.4. Now I can take up this path or I can take up this path. Agree? So I'm gonna define that. I need to tell my routers that no, don't take this path. Okay, might be this link is a serial link. I don't want this. So go over on this path because that's a better and a higher speed link path. So go over on this, right? So I'm manually gonna say, manually gonna configure a static route saying that go over on this. Configuring static route is good if you have like 1, 2, or 5, or 10, or 20. But in a enterprise or in a campus network or in a data center, the routing or the number of routing inside the routing table will be in hundreds, or might be there will be a lot of uh, what do you say, you need some protocol which can uh, have very critical timers. Let's say 1 second your routing is making a decision. Okay, so what happens in static, or what is the drawback of static, is a human intervention is required. Okay, so let's say this went down. Now you have to manually tell this router that go back from this route. So there is a human intervention in a case of static, and I cannot be always in front of my office computer, right? Might be I'm handling a P1 case, or might be I'm handling a site visit, right? The time that I need to go back to my desk and manually say that go via this is gonna bring a lot of outage, and my customers are gonna impose penalties on my enterprise, right? So static has some drawback. It's easier to configure, but it has some drawback. The second option that I am left out is dynamic. Dynamic is something which has a algorithm. Okay, it has its own algorithm. You just enable the process, they are gonna do the job. Okay, you just need to enable, sit, relax, they're gonna do the job, they're gonna find which is the better route, whether this or this, they're gonna take the decision. In case of one link gonna going down, you don't have to come and do something. It's making the decision that this is down, and let me send it from the second path. That's dynamic. Okay, now there are two different type of dynamic. One is called as IGP, interior gateway protocol, and the second one is called as EGP, exterior gateway protocol. Now here is what this comes into picture. If you have a LAN atmosphere, okay, LAN in the sense within your office premises. Let's say you are a network engineer for a company XYZ, of a IT park ABC. So you daily go to that office, and if something is going down in that office, so it's your responsibility. So that act as a LAN, local area network. Okay, so when you talk about IGP or a LAN protocol, you have three different protocols: RIP, EIGRP, and OSPF. Okay, three different IGP dynamic protocols. When in the case of EGP, exterior gateway protocol, you gonna have only BGP. That's the best one till date. Okay, there is no replacement for BGP, at least in the enterprise and from the service provider point of view. Okay, so these two domains are still making use of BGP, but there is an alternative in when we talk about the SDN network, especially in the case of SD-WAN. Okay, in SD-WAN, we don't make use of BGP. We have its own protocol, which is called as OMP, Overlay Management Protocol. Okay, so don't get confused. This is a protocol which is alternative to BGP in the case of SD-WAN. Okay, software defined networking. But in from the enterprise, from the service provider, and from the data center point of view, we still make use of BGP. Okay, and this is the topic that I have picked because a lot of domains are still dependent on BGP. Okay, and this is a topic in your CCNP enterprise as well. These are not the topic, these are just a brief introduction about them, whereas CCNP enterprise has a in-depth uh, topics, or it needs in-depth knowledge in the BGP protocol. Fine. So this was my first overview of the BGP, how BGP was evolved, and what type, where is BGP standing, uh, where is it used. Okay, it's used in routers and all those things. So in the next, so let me clear this. Okay, so let's talk about BGP now. So let's say I have a campus here, okay, ABC, and I got another campus over here, let's say XYZ. So this is my campus, right? Campus consists of three-tier architecture, or might be two-tier architecture, right? So let's say I have a router, I have a distribution switch, I have a access layer switch, and behind the access layer switch, I have multiple users sitting across. Okay, so this is a LAN. Let's say this is a local area network. Similar way, I have another campus XYZ with a similar three-tier architecture. This is a core layer, this is a distribution layer, this is the access layer, and multiple users. Okay, they don't have to be users, they can be file servers, there can be a DHCP server, there can be a monitoring tool, there can be n number of things, storage devices, or server, anything. Okay, and let's say I want to connect these two. So let's say user A has some requirement to upload some file on a server. Okay, so what are the protocols that we deal within a LAN? So a overview. Okay, so basically we have our access configurations between the access switch and users. So we are gonna have access VLANs. We are gonna have the trunking VLANs here. We are gonna have a dynamic routing protocol, IGP dynamic routing protocol. I can take up EIGRP or I can take OSPF. Okay, either one of them. And then over on the cloud, okay, that's nothing but the service provider. Okay, so let's say I have Airtel on my first service provider, and on this side I have Verizon, and in middle I have AT&T. Okay, so these are also consisting of routers. So let's say there are a couple of routers within these service providers, or we also call them as ISP, internet service provider. Okay, they also consist of routers. So you see the whole this part is made of routers, and we all know that routers understand or communicate over on a routing protocols. Now, which protocol are we gonna use? Do you think I am gonna use EIGRP or OSPF? No. These are LAN protocols. LAN in the sense within the campus, the protocol EIGRP and OSPF are within these campus. They are not meant for the WAN segment, wide area network. Okay, wide area network is something which connects two different LAN. Okay, so for a WAN, I'm gonna make use of EGP, and we all know BGP is gonna be that protocol which will be enabled. So I'm gonna have BGP process here. I'm I'm not gonna have the BGP process. Is the service provider who will have the BGP between them. I will not have any access on their network. So they're gonna have their own BGP. So the network engineers who are working for a ISP like AT&T, Airtel, they will have the access to their routers and they will configure BGP. Okay, and these are all made up of BGPs. So where is my involvement now as a service engineer, or let's say I'm working for the campus ABC and this. So my intervention is only up to this router. Okay, I'm gonna configure BGP from my side and on this side. Rest are all service providers, so they will have their own engineers who will configure and they will provide you the connectivity. Okay, so that's why this is one reason why we call BGP as a or internet, or we call BGP as a protocol of internet. Okay, because if you see from a broad point of view, internet is made up of lot of routes or prefixes, and just routing from one network to another route needs a protocol, and that's your BGP, right? So I can say that BGP is the protocol of internet. The whole this part, which is internet, after all, it's your BGP that's taking care of, right? So it's very easy for me to say BGP is a protocol of internet. Okay, and it's very important protocol from a technical point of view, and also from the certification, or also from your job point of view. Okay, Okay, now a simple question: why do we only use BGP on the WAN side and not EIGRP or OSPF, right? So you guys might be wondering that uh, let's make use of EIGRP and OSPF in the case of WAN. Why do we need a separate protocol, right? So the reason is these two protocol has multiple features which don't support to be one of the protocol in the WAN side. Okay, so like say for example timers. These protocols have very critical timers. Okay, timer in the sense the hello and the hold timers. So in the case of EIGRP, it's 30 and 90. Okay, and in the case of OSPF, it's 10 and 40, 10 and 40 seconds. So these are the timers which will bring lot of overhead on the router. So I mean to say, let's say there are multiple routers. Okay, this is a LAN, and you bring up OSPF on all of them. Okay, all of them are having the routing protocol as OSPF. So they start building neighborship automatically. Once they build the neighborship, they are gonna exchange the update. They are then gonna keep alive. So these keep alive messages will be sent every 10 and 40 seconds. Okay, so every 10 seconds you will see a keep alive originating. So that is one reason which is a drawback of not having in a WAN scenarios, because in the case of WAN, it's not about 10 networks or 20 networks you're talking about. WAN is consisting of 780,000 routes. Okay, so you understand the number. If you're sending a hello timer in this scenario, your whole internet will be just flooded up with the hello timers only. Okay, so this is one reason why I cannot bring these protocol in the WAN side. Okay, fine. So what about the second, or what about the rest of the things which don't support these LAN protocols to be one of the WAN protocol? Okay, let's talk about algorithms. What is the main algorithm, or what is the main decision maker criteria in the case of EIGRP and OSPF? It's your metric. Okay, metric is nothing but cost. In the case of EIGRP, I'm gonna see what is the cost, and then I'm gonna decide, let's send the route to so and so. So let's say this is one router, and this router is connected in this fashion. Okay, so let's say all of them are running on EIGRP. So in the case of EIGRP, what happens is, if I have to send something, I see two different paths. Okay, and I'm gonna see the cost now. So every interface is gonna get some cost. So let's say this is gonna have 10, 10, 10, and this cost depends on 5 components. That's your bandwidth, reliability, MTU size, uh, delay. Okay, and what else? I think I'm missing one: bandwidth, reliability, MTU, delay, and what else? What else? There's one more which I'm missing out. So anyone knows about the fifth component? It's load. Okay, so these are the 5 components which is gonna calculate the cost. Okay, and in the case of OSPF, it's your reference bandwidth divided by bandwidth that's gonna give you the cost. Okay, so these two protocol depend upon the interfaces, and then they are gonna decide the cost. Okay, now this is a drawback. When I'm talking about 7 lakhs of route, I cannot keep on checking which path has what cost and what is what. Okay, I need a protocol which is very stable, which I can manipulate as per my requirement. Okay. And in the case of BGP don't work on the cost or a metric. It works on attributes. There are 11 best attributes. Okay. Which is a advanced topic. Might be I will not be able to cover today. Might be this I'll take in the next part of this webinar. So these are 11 attributes. Some of them like weight, local preference, AS path, oldest path, okay, med. So these are some 11 attributes which are used to make the decision. Okay, so now you know what is the difference between uh, IGP protocol and a EGP protocol. Okay, so if someone asks you why don't we use a IGP protocol in a van, so you know why, because the timers are not gonna help me. I have 7 lakhs of routes in the internet. So do you think the keep alive uh, concept is gonna work? My routers are just gonna have lot of overhead on the memories, right? CPU, RAM, etc. And basically they will be just getting uh, explode one fine day. One is that reason. Second reason, the cost calculation. In the case of IGP, it's a different concept, whereas in the case of BGP, it's completely different. Okay, so that's make this two segment, that is IGP and EBGP, very different. So you cannot just cross connect them. Okay, fine. So that was second topic. Okay, fine. So let's say so might be you guys already know what is this topic called as. So let's say when I told that this is a campus, okay, and I have my OSPF over here, and let's say I have then the BGP. Okay, so how am I going to route my OSPF network inside BGP? What is that called as? So do you guys remember that? It's very very simple. I just asking you the word. What is that called as when I'm injecting one protocol inside other? Yes, it's called as redistribution. Okay, so where are we going to have this redistribution? It's over here on this router. Okay, so this router is gonna have redistribution where I'm gonna inject these OSPF inside BGP, and similar way the BGP inside OSPF. Okay, and this whole technology is called as redistribution. Fine, why do I need OSPF to be injected to BGP and similar way vice versa? It's when something is coming from this direction. Let me make use of a different color. So let's say something is coming from this direction. Okay, in this direction, so it's first hitting the BGP, agree, and then it's going to the bottom. So you need the BGP to redistribute inside OSPF. Similar way, let's consider you have a users and they're accessing Google or YouTube. Now the packet is flowing in this direction, agree. So from OSPF it's going to BGP and then BGP to outside world, OSPF and BGP. So this injecting of two different protocols are a concept of redistribution. Okay, great. So that's something about redistribution. Well, very important topic is key points of BGP. I'm letting this for a open forum. You guys can help me to understand some of the key points of BGP. What do you understand from the BGP? Or you can give me some points about the BGP. So you can talk about the timers, peers, which protocol layer it work, what is the OSI layer, or so and so. Okay, you're open to. Okay, okay, something technically you guys wanna add, which OSI layer? Okay, okay. Well, so I see a lot of guys adding their key points. Okay, it's a EGP protocol, or I can say it's a WAN protocol. Uh, so which vector does it follow? So which vector does it follow? Okay, path vector protocol. Great. Okay, fine. So it follows path vector protocol. Good to see people also said it's a TCP 179. Okay, and it works on, or it's a layer 7 protocol. Now I would ask you, TCP is a OSI layer 4, right? It's a transport layer protocol. Then why do you say layer 7? What makes you say it's a layer 7 protocol? Layer 7 is a application layer, right? So those guys who are not able to understand, we are talking about open system interconnect OSI layer, which has 7 layers. Okay, let's say this to be the 7th layer till your physical layers. Okay, you have presentation, session layer, transport layer, network layer, data link layer, right? So TCP UDP is an example of layer 4. Routing protocol, after all, we are discussing about routing protocol, which is dealing with IP addresses. So you could have also told it's a layer 3 protocol, right? Because when we talk about OSPF and EIGRP, they are a layer 3 protocol. Agree? So why is BGP you said as this out of the box? So any answer for that? So why do you think your answer is right, but why do you think it's called as a layer 7 protocol? Okay, so let me tell you what happens. Okay, so you guys are aware of OSI layer, how OSI layer works? So are you guys good with the OSI layer? Okay, so if I just ask you, where is the presentation and session layer seen? So what would be your answer? Where do you think you will see these layers, like presentation and session layer? Where do you think you will see this? Okay, not an issue. Okay, so as I told, this webinar is not to test anyone. Okay, it's very interactive. That's why I'm bringing up the possible questions here, so that we all are benefited. Okay. Okay, so let me erase this and let me talk little bit on OSI, not in depth. Okay, so let's say I have a computer in US and I have another laptop or a computer in India. Okay, a very simple example would be sending of an email. So when, let's say, I'm sending an email. Okay, so the email is sent to the person who is in India, and he reads it out, right? So this is something which we all know. But what is happening in the back end is something demonstrated with the help of OSI layer. It's a theoretical approach. Okay. OSI consists of 7 layers: application layer, presentation layer, session layer. And these 3 layers you will see within your system. I'm going to tell you where exactly. And the next 4 layers, that's your transport, network, data, and physical. It's something which you will see outside of your computer. That's the main reason when we have a practical approach called TCP IP, we call this as a software layers. Agree? This was called as software layers, and this was called as a hardware or a networking layers. So these 3 layers, the top 3 layer, application, presentation, session, that's seen within your system itself. Application in the sense, the applications that you use, like for example Chrome browser, or a WhatsApp application, or a Skype, right? They are all application. Now, as a network engineer, these applications are of not an importance to me. Okay, the port number that they respond to, that's of a importance for me. Where is Chrome responding to? It's responding to HTTPS or HTTP, right? And they have their own port numbers like 443 or 80. Agree? Similar way, let's talk about web, something like WhatsApp. So it's designed to have its own port number. Let's say talk about Skype, which runs on a VoIP technology. It's have its own protocol number. Someone who doesn't know what is this, so let me tell you. Okay, there are list of port numbers, and these port numbers are being given by INA. INA is a online entity which also gives IP address. Okay, and if you ever get a chance, just check it out. These are the port numbers, and the applications are responding to this port number. If you see my HTTPS, for a software point of view, or a software engineer, or a common layman example, or a layman who doesn't know networking, for him this would be HTTPS. But for me as a network engineer, it's not HTTPS, it's the port number that's HTTPS responding to. Okay, so it's responding to the networking port number 443. That's your HTTPS. Okay, very important things which you need to remember. Okay, so these are the port numbers which your softwares are built up. Okay, so all the port numbers are responding or associated with the application. So once, let's say, you are making use of a Chrome, the port numbers get triggered up. The port number is then gonna send those information to presentation. Presentation layer is one which is gonna convert all the text, graphics, images, videos, or some security data accordingly to a computer readable. So let's say if you're talking about text, it's gonna get converted to ASCII. If you're gonna talk about a JPEG, let's say your email has something for a JPEG. JPEG is an image. Okay, so they are gonna get converted to the format like PNG or JPEG. So basically, I should have written it as image. Okay, if you have a image in your email, they're gonna be getting converted to JPEG, PNG. Okay, let's say you have a video within your email, that's gonna get converted to MP4 or MOV. Okay, similar way, you have some security concept when you are dealing with bank transaction. Let's say this is your laptop and this was your banking website xyz.com. So you make use of HTTPS to secure your username and password, right? So that also get converted. So presentation is gonna just convert all the human readable to something which computer can understand. It's acting as a translator. Okay, and then it's gonna present it to the session layer. Now, session layer is something which is going to keep a session of every individual tab. So let's see, if you see my screen, there are multiple tabs, right? So let's say if I open up my Gmail, okay, and I have one ID logged in. Now on the different tab, I'm gonna use second instance of Gmail ID, and I'm gonna make use of second email ID, right? So while receiving an email, do you think that email somehow comes on the second instead of the first? No, right? It's because the session is getting created in the backend. So whatever email you are logged in, so that's your session one. Okay, and if you're receiving or you're expected to receive something, you're going to receive on that session itself. So you can take it as a tab or a different tabs or different application. If you're making use of WhatsApp, you are also receiving back the information on the WhatsApp itself. It's creating a session from end to end. Okay, that's a session layer. So once these three layers are being completed, we are gonna offer it to transport layer. Transport layer will add the UDP or the TCP headers. Okay, uh, something which is very important again. In very short, I can say TCP is a reliable protocol which uses three-way handshake. UDP is unreliable. Okay, the best example for TCP is your banking transactions or banking login. The best example for UDP is your Skype or a video conference. Okay, so it's gonna add the headers, it's gonna send to network. Network is gonna see who is the source, who is the destination, route the packet. Data link is gonna add the correction, okay, layer 2 data correction or layer 2 ethernet frame corrections, okay, CRC, these mechanism. Then they are gonna finally send to the physical layer, which is nothing but your analog signal. So you can see the analog signals going across. Okay, and once it receives here, they're again gonna be retranslated or decapsulated into 0101 format, and they just climb again. So physical, they go to data, data to network, network to transport, and so on. So the headers keep on moving, okay, moving out. So the reason why I just gave you overview of OSI is because you said BGP is a application layer. Okay, whereas if you talk about routing protocol, they are either networking, or in the case of BGP, it's TCP that's you're gonna add, right? So the answer could have been transport as well, but the right answer is application. The reason is the application is initiating those packets, right? And over on the TCP header, you're pushing the communication. So that's why we call it as layer 7 protocol, which is making or which is sitting on the top of TCP. Okay, or let me write in this way: BGP is a layer 7 protocol that sits on the top of TCP. Okay, the rightful definition of BGP. So if someone asks you what is BGP, never tell layer 3, but because the other protocol like OSPF, EIGRP are layer 3. Okay, so the rightful answer is the layer 7 protocol that sits on the top of TCP, because it relies on the TCP mechanism. Okay, and who is initiating this? It's those application which are pushing this protocol to be initiated. Fine, fine. So let me clear this. And what is the time? Let me just see the time. So my mic is and I'm already screaming actually, so I don't think it's a problem from my side. So just check it out on your end. Okay, okay. So what else, or how is BGP working? Okay, or how does BGP works? So let's say I have two autonomous system, or let's say two campus. XYZ, and ABC. Okay, and I have the routers here, and they are connected to service provider, and I have BGP between them everywhere, right? So in the case of BGP, we make use of something called as AS, which is nothing but autonomous system. Okay, who is giving you the autonomous system? I'll come to that point. So let me write it here. So let's say this is a autonomous system with the number 35,000. This is autonomous system with the 45,000. This is autonomous system with 50,000. Okay, this is autonomous system with 55,000. This is autonomous system with 60,000. Okay, so this is very important thing, or very important concept in the BGP. In BGP, you need to know the AS values. Okay, and the BGP routes are gonna be propagated across different autonomous system. So autonomous system is nothing but the complete administrative uh, component where you have some policies. So let's say under this administrative uh, in this administrative group, you have some set of policies. You're setting up so and so policies, right, which remains within this enterprise or within this component. So that act as one autonomous system. Similar way, if you see, there is an autonomous system on the uh, ISP side. Let's say this is a AT&T. It will have its own policy, its own mechanism, its own path attribute, right? So it forms one autonomous system. So that's very important thing. And who is giving that? It's your INA, okay, which assign this autonomous system. There are multiple entities like RIR, regional entities, and also there are some local entities, LIR. Okay, so if I take enterprise connection from Airtel, AT&T, Vodafone, Verizon, they are regional entities. If I take from a smaller ISP providers like city based or a town based, okay, in India we have ACT, we have some TTN kind of internets, Hathway. So these are all small brands. Okay, they buy eventually from the RIR. Okay, so but yes, for some companies they go with LIR. Okay, so these are the people who will give us the AS, and these people are getting it from uh, the AN, from the INA group. Okay, the internet uh, groups. Fine. Why is AS important? Because when I'm sending a packet, so let's say when I'm sending a file, my file will be taken up in this direction. Okay, I don't want my packet go towards midway and for some reason come back, right? That's a looping concept. When I'm sending something and it's coming back to me, it can cause a loop, right? So what I make use of is I make use of the AS number. So what happens in the case of BGP is, so let's say I'm sending a file. Okay, I'm sending a file. So my file hits this AS, and there's a tagging happening. So my file will have a tag of 45,000. That means my packet, which is containing this file, is propagating from this AS. Then this AS is gonna send to the second AS. Now my file will get another tagging. Okay, so this is the tag that was given by this. There will be one more tag, and then it will be pushed to another AS, and so on. The AS numbers get added up. Okay, you have 5,000 and you have now 55,000, and finally it reaches over here, the destination point. So now you have very clear visibility how your packet is going. So your packet went from AS1 2 and 3, or you can also say it went to AT&T, AT&T to whatever Verizon or Vodafone, whatever I considered, and then it went towards the different protocol, and finally it arrived here, right? So this way I also make sure that there was no looping happening, because if ever the packet comes back, and if the BGP see that there is a autonomous system already, it's gonna discard that packet straightforward. It's not gonna send back, which was causing looping, right? So that's why AS is very important from the looping point of view, and this AS gets added up for every internet route or every prefixes. These are the AS that's gonna get added up. Okay, it's not that optional, it's mandatory. It's by default getting tagged with your traffic every time it gets added up. Okay, there are a lot of things in AS which I don't think I can cover in such a detailed way. So the things like, if you see here, there are something called 4-byte AS. Okay, in short, let me tell you, we had 16-bit AS only, which was supporting from 0 to 65535. Okay, but as you know, there are lakhs of internet prefixes increasing. There are a lot of companies coming up. So this is very small number, right? So now we started up something called as 32-bit, and if you just do the translation, 1 byte is 8-bit, right? And 4 bytes are nothing but gonna be 32-bit. 8 fours are 32. Okay, so I had a 16-bit initially, and now I introduced something called 32-bit, or something called as 4 bytes AS. Okay, or ASN value. Now, what is this gonna support? It's gonna support this range, which is a very huge number. Okay, so I might take a help from Google. So let's say 2 to the power 32. So this is that number, and this is the current AS numbers that we have overall. Okay, fine. So now a question to you guys. Let's say I have a campus network which was using BGP, and my ISP had given it a 16-bit AS value. Might be it has given it 65,000. On the other side, now let's say this is a new campus site, and the ISP here has given one of the number from this 32-bit ASN value. Might be something we just saw, like in for 4 lakh something, right? So something that. So my question is, if during during your interview time, if someone asks you that on one side I have the 16-bit ASN value, and on the second side I have the 32-bit ASN value, do you need a special configuration to have them reachability, or they are gonna fail? There's no way you need to get them both in 16-bit or both in 32-bit, or there is some way we can fix this, or there is some special configuration required, or by default they are gonna take it. So let's say I have 3 options. Okay, first option, no, it will not work. Second option, special configurations required. Third configuration, yes, it's gonna work by default. There could be some mechanism. So which one do you think is gonna be? So what else? How about the other guys? So where are other guys? So I have 14 participants. Where are other guys? So no one wants to contribute. I see two answers as of now. Give your best answer. It doesn't matter. It doesn't matter if you're right or wrong. Okay, fine. So let me tell you, the right answer is this, the third one. The reason is, in the case of the second or the latest 32-bit or a 4-byte ASN value, we have a concept of AS dot plus. Okay, so basically, I can say that these 32-bit ASN can be written in three ways. Okay, one, AS plain, which is nothing but from 0 to 65535. The second one here is AS dot plus, and the third one here is AS dot. Okay, I don't want to go once again in very depth because this is a webinar. I don't want to put this into very what do you say, a boring kind of class. Okay, so let me tell in this way that AS plane is something which is 0 to 65535. AS dot plus is 0 to all that 4 lakh whatever we saw, and AS dot is something which is backward compatible. That means you can have AS plane, and on the second side you can have AS dot plus, so they're gonna be backward compatible. So in this scenario, even though I have 65,000, so what happens is they are gonna get converted to AS dot, so something like this they are gonna be written. And similar way on the 32-bit ASN which follows AS dot plus, they are gonna have their own values, something like this. Okay, rough example, and they are backward compatible. And if you guys want to see a live example, you guys can uh, make use of a online converter also, which is called as, okay, you can just convert the ASN format. So let's say if I take 65,000 and if I convert to the latest one, so they are gonna be converted into AS dot plus format. Okay, and now let me take one of the value from here, or let me take the this value itself. Okay, so this value will also get converted in this format. So that's how they form the backward compatibility. So you can see this. So one side you have 0.6535, and on the second side you have this. So this will automatically get converted, and they form the backward compatible. You don't need any special command. They will recognize that. Okay, so ASN allocations, all those things, they are done by the RIRs. Okay, so who is gonna give this? They are given by RIR. Okay, so there are 5 regions, like African regions. Okay, there is a AP NIC, which is called as Asian Pacific. There is AR IN. There is a Latin America, and there is something called uh, RIPE. Okay, so different continents like European, all those things. So these are the 5 RIRs that's gonna give ASN values. Okay, and let's say I'm being from Asia, I'll take from one of the service provider. That could be AT&T or Airtel or any of the supreme RIRs. Okay, and there will be also LIR, the regional or a local internet entities. Okay, so basically they also give ASN values. Okay, so that was regards to the BGP working. The last two topic which I'll take here would be BGP peering state. Okay, I'll just go with a brief intro, and might be I'll go with the last topic as okay, might be I'll just cancel this for today and we will go with Q&A. Okay, I've not done a lot of question because I'm not sure where you guys stand and all those things. Okay, so depends on how the first webinar goes, and if you want more, I'll bring up. Okay, so let's say BGP peering state. That's when you have two routers, you configured BGP, and you want to form a neighbors, or let's say they want to form neighbors. So what happens in the back end? What are they classified? Okay, so they are basically classified into like 5 states. So first one called as idle state, you have connect state, you have active state. Okay, you have open sent, open confirm, and the last one being established. Okay, so let's say when I enabled, let's say I have a brand new routers, and they're still in a configuration phase. Okay, so such phase is called as idle phase. So idle phase is when it's admin down. Okay, it's admin down. Or I can also say idle is a state when BGP process is retrying the attempts. Okay, or I can also say idle is one such state where I just configured the configuration. I just configured the configuration of BGP on the router. So it could be any one of them. Let's say it was a brand new, it was initially down, it was configured, and now they are moving on to the next step, that is connect state. Okay, so connect is one such state where the TCP will initiate. Okay, TCP is nothing but the three-way handshake. Okay, the three-way handshake will start, it will initiate. So what happens is when I configure IP address here, when I have the BGP process within, a hello packet will be initiated. Okay, a hello packet will be initiated, which will be sent on TCP 179. Similar way, there will be another hello packet which will be sent to the router 1 on TCP 179, and that's when you have the three-way handshake first. Okay, what else do we see in this? So in this, I see, or I wait for the three-way handshake to get completed. If it's successful, let's say if the three-way handshake goes successful, I will move on to the next step. That's not active. Instead, it's open sent. I'll tell you why open sent. Okay, if it is successful, it will go to the open sent. If it isn't successful, okay, unsuccessful, then it's gonna go to active. Fine. And if BGP gets reset, BGP get reset. It went from idle to connect, and after connect, it's going reset. Then it's going back once again to idle. It could be a reason where it is retrying. It's not getting established. The reason could be TCP 179 is blocked, or you do not have an IP address, or it could be any reasons. Okay, so there are three approaches in this step. So depending upon the scenario, it can go either of them. Let's say if it goes to active when the connect was unsuccessful, active state. So it's a scenario when the TCP is not getting connected. Okay, TCP not getting established, or the BGP is still trying to have three-way handshake, but it's not coming up. Okay, so let's say three-way is still not getting established, or you see the timeout error with respective to three-way. Okay, or it's a state when BGP is still listening for an incoming TCP connection or a TCP connection from the peer router. So these are the symptoms of active. For some reason, the three-way handshake goes well, it will be put to the next state, that's called open send. Open send is a good example. Okay, open send is when you have a TCP done, you have the uh, TCP up, good thing, which is nothing but your three-way handshake is up. Okay, and what else? What else do you see in the open side? So maybe you are expecting the second side of the router to send you the open message. Okay, you just gone or you just completed the TCP step. TCP is not a BGP packet. It's the mandatory step before you send the BGP packet or a update packet, right? In the open send, it's when you have TCP up and the three-way handshake completed, and you're waiting for the open message from your peer router. Okay. So what is next step? So let's say open send was all done and it moves towards open confirm. Open confirm is a good news once again. Okay. It's a state when BGP, the two BGP routers can send and receive an open message. Okay. It can also send and it can also receive an open message. Now, don't get confused with these messages. This is a next topic which I'll take in the next webinar. Okay. So these are BGP messages. Hello, keep alive, update. Okay. So notification. These are some messages. So these are sending uh, open messages. Now they are sending and receiving in the case of open confirm, and they are setting up a keep alive. Why do we use keep alive? It's to see if the peer router is still up and running. Okay, we don't want our peer to be down and we don't know, and we are still forwarding to that peer itself. So we make use of keep alive. Okay, and establish this one when you have gone through all the parameters are matched. Okay, you have a adjacency now. You have exchanged all the routes. Okay, you have exchanged all the routes and you are a happy neighbor now. Okay, the two BGP routers have exchanged the routes. They are formed the complete agency. They have gone through all the neighbor parameters and all those things. So these are the state in the case of BGP. Okay, in the case of OSPF and EIGRP, it has its own states. In OSPF there are 7 state, right? The down, init, two-way, extract, exchange, loading, full, right? So this is very similar in the case of BGP protocol. In the BGP protocol, these are the states. Okay, fine. So as I was talking about some messages, so I'll just quickly tell you there are messages like open messages, update messages, and keep alive and notification. Okay, so these are some BGP messages which we saw here, over here, and over here. Now I'm asking you one question from your experience point of view. Okay, so let's say in my BGP routing table I happen to see idle or active. Okay, so do you think that's a good example, or do you think that's a bad thing? There might be there's some issue with your network. Okay, so you say it's a bad thing. Okay, yes, so it's a bad example. Okay, active or idle is nothing but when you do not have your uh, TCP coming up. It's a scenario when the three-way handshake is stuck. It's a scenario when there could be TCP 179 getting blocked. There could be scenario when you don't have a successful IP or a router ID which can initiate the process, right? Those are the scenarios when you are stuck with the BGP agency or BGP neighbor, and such scenarios you will see listed as active or idle. Okay, the best example or the good example should be if you see the timers. Okay, if you see 10 seconds, that means the neighbors are been stable for last 10 seconds. If you see something like this, like 1 hour or so, that means they are up and running for last 1 hour. Fine. So those are some indication which we can do in the lab. I had the plans to take the lab or at least show you my CCNP topology. Okay, so basically what I do is, so here is where I take the basic CCNP BGP topics. Okay, to show the packets, BGP packets, the peering states, the messages, all those things. Okay, and as we move on, we have a dedicated part, okay, where I talk about attributes. So this I have for path attribute, and here I let the student practice on attribute like local preference, med, and AS path. Okay, so we have a dedicated portion for CCNP practicing on this. Well, so might be I take one lab in the next class where I show you the packet flow over on a Wireshark. I show what are the uh, parameters we see in the case of agency. Okay, there are many more concept like there's a concept called as, might be you guys know about that. It's called as active and passive BGP peering. Okay, so you will see that one of, so let's say when you have two routers, one of them become active and the second one becomes passive, so they are gonna get the role of TCP 179, and which we can see only when we have a Wireshark. Okay, so one of the router is gonna have that TCP 179, whereas in case of OSPF, if you have two routers, they work on multicast. If you're sending something, the source and destination will be accordingly changed. You're sending to this router, and the router is listening on a multicast IP, let's say this. Same way, if you send vice versa, you have multicast IP once again. But in the case of BGP, it's one router that's gonna take 179. So no matter who is sending, who is receiving, is that router who which will take this 179. Okay. So these are some topics, advanced topic that we cover in the class, okay, which is not really possible in webinar concept to cover each and everything. Okay, so what else was I about to show you guys? Okay, so I have a quick uh, few questions. Okay, I want to keep this very interactive. I can also unmute you guys. Okay, so these are few very frequently asked questions. Okay, I just want to know your understanding from your point of view. Okay, let me unmute you guys. You guys can unmute yourself, speak out, and then place yourself on mute once again if you're done with your answer. Okay, so that the next person can take the chance to speak out or answer his point of view. Okay, so the first point here is, or the first question here is, let's say explain border gateway protocol. So you just let me know the few points, and I am gonna place it here. So we have discussed already a lot of things. So might be you guys can unmute and give your own points, and I'm just gonna write them here. So what do you understand
Yes,
by
hi.
B? Sorry.
Hello. Yes, hi, this is
Yes.
John.
Yes. Go
Yes,
ahead. Yes.
calling in from Nigeria. From my understanding, border gateway routing protocol is a path vector routing protocol, and it's
Okay.
a layer 7 protocol that sits on TCP.
Yes.
It
Great.
uses the TCP port 179, and
Okay.
it can also be called a WAN protocol, and it's an EGP.
Okay. Okay. Great. Okay. That's a good answer. So the guys can if anyone has any additional point, you can let me know. I'll add it. Otherwise, I'll move on to the next question.
So Sagar, I
Yes.
want to add like it used to connect between two sites using internet. So whenever we are using internet to connect between sites, we can use BGP. And
Yeah, we don't have any other option. Do you think there is
yes,
any other option? Yes,
uh,
I can write it as internet protocol.
yeah,
Okay.
and it holds lot of routes, all the internet
Okay.
routes, all the internet routes.
Okay. Yeah. So I can write it's like seven lakhs of internet routes. Okay.
Yeah.
Great. Fine. So let me go to the second question. The second question is, can routers on different subnet become BGP neighbors? Let's say, okay, this is Airtel ISP, and this is myself, enterprise. I have here 1.1.1.1, and over here I have a different subnet, 2.1.2.1.1.1. Do you think they will form neighbors?
I guess it cannot.
Okay. What about others? It's an interview question. Let's say someone asks you during your interview. You're gonna answer. You cannot be silent, right?
Yes, it is possible.
Okay. How about others?
Yes, I think it's possible.
Okay. Yeah, it's possible. The reason is, if you have ever configured BGP, we start with BGP process or autonomous system, and I'm gonna define the neighbor IP with the remote AS only. I don't mention mask anywhere, right? So it doesn't matter really what is my peer IP configured on, what subnet he is falling under. My neighbor statement is always in this format. So let's say while I'm configuring on router R1, I configure neighbor 2.1.2.1.1.1 remote AS, and whatever the AS this has. So let's say it has 20,000 and I myself has 10,000. So I'm gonna say 20,000. And what about that person? How is he gonna configure from his end? He's gonna say router BGP and whatever his AS is. He gonna say the neighbor is 1.1.1.1, and the remote AS is 10,000, right? So I'm not gonna make use of any with the subnet mask. So the answer is, they don't have to be falling under same subnet, right? So the answer is yes, they can still form the neighborship if if they are in a different subnet. Doesn't really bother me. Fine. Okay. Great. So let's move on. The next question: what TCP port number BGP use? A very quick answer.
179.
Okay. Great.
It's a 170.
Okay. Yeah. Okay. Great. Difference between eBGP, IBGP, though we have not discussed, but I'm not looking for very technical answer. Give me very simple answer. What exactly is the difference between IBGP and EBGP? Or if you can give very good answer, that's also fine with me. I don't mind.
The port numbers are different.
Port numbers. Okay.
For different. Yes, it is 179 and 20.
No, you're confused. 179 is TCP port number, and the 20 that you're talking is the AD value. They are two different concepts.
Okay.
So you have missed. You are trying to combine two different things here.
Okay, I think the AD value. I think, right.
Okay, so if you say AD value, then this is 200 and this is 20. Okay.
20, yes. Okay.
Both work on 179 only. What else? What else is the difference between IBGP and EBGP?
EBGP basically for connecting to different AS numbers, and IBGP for within AS. IBGP requires the full mesh connectivity. Otherwise, you need to go to some other mechanism as route reflector or other things.
But why do I need full mesh or route reflector? Is it really required for me?
Yeah, it's if you thinking a design perspective, it's really required because if you the BGP basic fundamental is that for preventing the loop, it will not forward the routes. It's learned from the same AS to
Okay. So yes, your answer is right, but it has to be rephrased. Okay. So let's say these routings, or let's say about switching. Okay. So these are the two protocols that we majorly use. In case of switching and in case of the routing, the most nightmare would be the looping. Okay. Looping is something, let's say you're sending from A, it goes to B, and instead of going to C, it's go back to A is sending back to B is sending back to A, and this is called as looping, and this will impact the whole production, or it will impact the whole network. Okay. So in the case of switching, the loopings are really a nightmare because there is no way you can uh, avoid the looping until you fix them manually. Whereas in the case of routing, we make use of the concept TTL, time to live. Okay, so maximum is 255. Even if they circulate for 255 times, might be the routing loops can still get expired automatically. But switching loops are very dangerous. Okay, so don't have switching loops, and to prevent that, we have spanning tree protocol in the switching. In the routing, in the case of loop avoidance, we make use of a concept called a split horizon. Okay, and this split horizon is seen in EIGRP and BGP. It's not seen in OSPF because OSPF is a link state vector which has all the information of all the links from all the areas. So there is very least possible of having loop. Whereas in the case of EIGRP and BGP, one is distance, one is path vector. They don't know the entire flow of the path. Okay, they don't know, they just send to the neighbors, and then the neighbor will take care to the other person, and so on, they moves on, right? So there can be loop avoidance. So in the case of BGP, by default, when we have the eBGP concept, I said that AS numbers get tagged with all the packet flow. So that makes easier for me to avoid looping. But in the case of IBGP, since IBGP is within one AS, so there is no point of adding AS value to the packet, right? Because one router to other router, they are gonna have the same AS value. So how are you gonna avoid looping in that scenario, right? So in that scenario, you make use of split horizon, which is a loop avoidance. Okay, and by default, what split horizon says is, whatever you learn, let's say whatever is this router learning, okay, he is not gonna send that information to the next person. That's a default behavior. And let's say I form a network, something in this way, and if they don't pass on the information, might be this person and this person will not have any reachability. So to have that fix, we either go with full mesh or we go with route reflector. Okay, these are used in IBGP. And why we use that? Because of that default behavior of IBGP. IBGP say that if I get something from router A, that's gonna be between me and that router A. I'm not that I'm gonna send it to router C or router D. And due to this default behavior, the router A cannot talk to that router D. And to fix that, or to have a reachability, complete reachability, we make use of full mesh. Full mesh is something where all routers are connected virtually. Route reflector is a concept where we select one BGP router as a server, and this server will be connected to multiple clients, and all of them talk to the server, and server will be talking back to the clients. Okay, client and client will not talk to each other. Fine. So that's a little bit on eBGP and IBGP. Well, so this is something you guys answered. So AD is 200 for IBGP, and AD, administrative distance, is EBGP. For EBGP is 20. Explain the loop prevention mechanism. Just now we went through that. Again, one of the interview point of question. Do we need to follow three-way handshake process to establish BGP connection? Yes, we need, right? So that's the first step we see in the BGP peering state that we went through today. What is the difference between hard reset and soft reset? Now, this is a question to you guys. Hard reset and soft reset, and the commands are here. This is the command which we use for hard reset, and this is the command we use for soft reset. So what do you think are the difference here?
I think the hard reset, it reestablishes the BGP, right? It clears the BGP neighbor and reestablishes it again.
What about soft would be then?
Soft, I think it just refreshes the root in the
Okay,
BGP.
so I would say that in the hard reset, the TCP 179 or three-way handshake has to be re-established, okay, between the neighbors. Whereas in the clear IP soft, you don't have to re-establish. It will be just a route refresh that you told just now. Okay. What are the different BGP message? Don't wanna include this. Okay. We just had very few minutes for this topic, okay, which we checked at the end. Different states we discussed today, very important thing. Okay, go back, and might be this recording videos you can go back and check. What is route reflector and why is it required? We all know that in the IBGP, the default behavior for a split horizon is don't advertise the routes internally. Okay, it will be between the two neighbors. They're not going to advertise to the next person. And to have the reachability overall, we need to have a full mesh or a route reflector. Problem with full mesh is they need to be virtually connected. Okay, if I have 4 routers, okay, let's say this is 1.1.1.1 and this is 4.4.4.4, and if I want to reach this, I can only maximum reach till B and C. So I start having full mesh. Full mesh is something where I logically build neighbors between these two routers, and I can also build a neighborship between these two routers. So all of them should have a neighborship relation. Okay, so basically you're increasing those BGP messages, the notification messages, updates. So basically the overhead on individual routers are increasing. So that's not very good or the best practice. Okay, so we go with route reflector. Route reflector is a concept where we have one server acting as route reflector. Server in the sense the router, BGP router, and then you have different clients connected. Okay, so client talks to server, and server will then pass on the information to the different clients. Okay, what is recursive lookup? Anyone who wanna contribute? So anyone wanna contribute? Okay, so let me tell you, in case of BGP, we call BGP as a recursive lookup, okay, because it checks twice in its routing table. The first time it checks for is the destination, how to reach the destination. So let's say destination is 4.4.4.4. Who is gonna send, or who is gonna send this person to 4.4? It's this, right? 2.2.2. So this is the next hop I can see. Second lookup would be, how do I reach this 2.2.2.2? Is it via dynamic routing protocol? Is it a directly connected interface? So it is doing the second, or the second time of lookup to reach, to see how do I reach this next hop. So there are two steps in the BGP. The first step, how do I reach the destination and who is my next hop? And the second lookup is, how is my next lookup placed in my routing table? Is it directly? Is it via dynamic routing protocol? So that's why we say it has a recursive lookup in the case of BGP. Okay, one scenario based question. So let's say if you ever see the BGP showing as this, so what could be the reason? If you ever see the BGP as 0.0.0 as router ID, what could be the
locally connected subnet?
No, that's something different. When you have the next hop as this, that means it's locally connected. But I'm talking about when the router ID is shown as this. I'm not talking about the next hop. Next hop is something which originate automatically to just tell you that I am locally originating.
Means
But
there's
I'm
the no
talking.
means there is a no router ID. It's basically be seen in the MBGP when you have the IPv6 complete subnet and you don't assign the manual router ID.
In
It is a
simple words,
server.
how, sorry?
Maybe the router is acting as a server.
No, it's very simple. It's very simple. Maybe you guys are taking it in very high level. It's very simple. If you just see a router ID to be 0.0.0 in any protocol, not just in BGP, in OSPF, also if you see 0.0, then that means something. That when do you get router ID 0.0.0? See, there are three ways of configuring router ID. One is
when you manually did not assign the router ID, or there is the no active interface which have the IPv4 assigned.
yes, you're right. So router ID 0.0.0 is a scenario when you don't have any active interface, or you don't have any manually router ID configured. And in that case, you will see in a debugging message that router ID is shown up as 0.0.0. And that's the reason BGP is not able to initiate. Okay, that's a debugging line of where you see this. Okay, so how many questions do I have? Okay, so last two questions. Okay, if you see the BGP is stuck in idle or active state, what should you do, or what could be the reason? Let's say in that way, if you see idle or active. So we discussed already, might be 179 is blocked, might be router ID is 0.0.0. Anything else that you think about, if they are stuck in idle or active? Okay. So I guess this should be pretty much enough. Okay, you can check the access list if they are not being blocked, and you can make sure the router IDs are configured. Okay, and this we discussed already, the split horizon concept. Okay. So guys, that ends the webinar. Okay. So I want to understand from you guys, how was it, and was it informative? Do you need the next webinar, or are you all drained up with the first webinar? Do you think this is all enough and so, or did you, or was it very boring, or you might not be learned anything new or something? So yes, your feedback could be really appreciable. So yes, you guys can definitely speak out so I understand.
Yes, Agar, that was a very good webinar. I really appreciate your effort, and it's a good pressure for me. And
Okay.
I would like to say like I need more classes from attribute basis. Like I need to dig in that because basically I don't know that expertise in practical level. So I need to know that if it is you are conducting that attribute level of classes, it will be very appreciated.
So the thing is, as you know, okay, might be I have not told you. I have the new CCNP batch starting up. Okay,
Okay.
it's starting from 4th July. So might be if you wanna enroll, then let me know. So basically, I have a new batch. I already have a ongoing batch from March, and the next batch is starting July. So if any of you wanna join this batch, you are all welcome. Okay, and from the free webinar point of view, I need to get some time from this training and all other stuffs and all, so that I can take a class. Okay,
Sure.
but yeah, I will definitely plan for a webinar where I can share some of the attributes and do some scenarios. Okay, this lab is very good. So basically, I give this lab to uh, the students who enroll. But yes, you guys can download a free copy. Not the lab you can copy. You can just take the topology and you can build yourself. And there are free workbook also. This is if case you don't want to enroll, and I'm not forcing anyone. Okay, if in case you want to enroll, you guys can enroll, and if not, you have to wait for my some free videos that I post on my YouTube, or might be you have to wait for my next webinar whenever I take up. Okay. Okay, question number 14. So what is question number 14? Question number 14 was when the neighbors are stuck in idle or active state. So I told you the two states which are considered to be bad, right? The next state like open confirm, open send, established are the good examples. So these are the two states when you see the BGP are stuck and they're not going further. So anyone have any doubt, you can unmute yourself and you can ask me, or else I'll just wind up.
Hello?
Hello, yes.
Yes, just one question. I want to ask if this the session of this video will post on your website.
Yes. It will be posted on the YouTube channel. So you can see already there are a lot of guys watching online. So it will be posted up on this. So are you on that WhatsApp group which I created?
Yes.
Okay, so I'll give the YouTube link after the session. Okay.
Okay. Another question. If we can run your lab on EV. I don't
Yes,
know if
you can run on EVNG. You can run on GNS also, GNS3 as well.
Okay.
Yeah.
Thank you. Thank you for the support.
Okay. Well, guys, so I take a break now. Signing off for now. I hope the class was informative and you really liked the interaction and the presentation. First attempt what done for having a webinar, because so far I never created a webinar. I used to take a instructor-led training. This is the first attempt where I thought of giving a webinar. Okay. So yes, subscribe to the YouTube channel and let's be in a touch over on LinkedIn. You guys will be getting update from me on a free content, also about my upcoming batches. I have a lot of courses which I have pipeline, like SD-WAN, firewalls, combo firewalls, load balancers, and as you know, I have network automation and CCNP enterprise starting from 4th of July. Okay. So yes, let me know, ping me or email me if you need any help or any assistance. Happy to help you. And signing off. Good night from India. See you all. Okay. Take care.